Hi everyone. So today we're gonna look at another chapter from our Collins International Primary Maths, right, for our Year 6 book itself. So today we're gonna look at Unit 2, uh, Lesson 3, basically 2.3 if you're in my class. It's factors, multiples, and also prime numbers. So factors you have already learned in one of the videos before. So have a look at that video if you don't really remember, okay? So in your textbook, you have an explanation of what is a prime number and also maybe an example right over here. But just from looking at the textbook, you definitely would not understand anything. So unless you really understand, then that's a good thing, right? If you don't, have a look and continue watching the video. So first thing first, let us write down in our notes the topic itself, factors, multiples, and primes. So if you want to make it more complete, you can write there factors, multiples, and prime numbers. It's the same thing. So factors, yes, we've learned before. Factors are basically the numbers that are inside your multiplication. Now, when we find our common multiples, it is basically the same thing as common factors like we did in our previous video or previous classes before. So it's basically the same thing. Sometimes in the questions you see, please find the common multiples or please find the common factors. So you can write both down so that when you're doing a revision, you'll somehow remember like, oh wait, they're the same thing. So you don't have to worry so much about it. So first thing first, for common multiples or common factors, we need to have a list of numbers. Then we find out what are the same numbers that both numbers have, right? The same factors that both numbers have. So let us look at 7 and 8 right over here. So we're gonna go up to 7 times 10 and 8 times 10, right? Let us list down every single one of them. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, and it goes on and on and on. So at 42, we have, let's see, 49, 56, 63, I'm trying to find the numbers on my keyboard, so sorry about that. We have 8 times 1, we have 8, yes. We have 16, we have 24, we have 32, we have 40, we have 48, we have 56, we have 64, 72, and lastly 80. So all of these are up to times 10, and that is all. That is enough. Sometimes questions maybe they ask you to go up to maybe 20. It depends on the question, but in this case it's just an example. I'll just show you how you can find out what are the common factors or common multiples. So we have to have two same factors for it to happen, right? Normally they will ask you to circle, but this time I'll highlight it for you so you can see it much more clearer. Now both numbers do not have 7, both numbers do not have 8, both do not have 14, both do not have 16, 21, 24 don't have, 28, 32 don't have, 35, 40 don't have, 42, 48 don't have, 49 no, 56 yes. So we have 46, and that's the only number they have to say in common. Well, over here. So one thing after finding out, and once you're really sure about it, you have to write it down right over here. The common multiple for 7 and 8 is, because there's only one number, so we put there is. Unless you have more than one, then you have to put R, your English. Plural and singular, right? Is 56. So this would be your answer right over here. So let me just make it smaller, too small. Okay, so this is how you're gonna answer in your book, or basically not in your book but also in your exams. So normally, please find the common multiples. You have to list this out yourself. You have to write it out yourself. They're not gonna give you every single thing. They're not gonna spoon feed you, basically, right? So next thing after common multiples or common factors, we're going to look at prime numbers. So let us look at prime numbers. So a lot of people, they cannot remember what are the prime numbers and all. I would say take your time. Most people would memorize all the numbers. Most people would actually do this step that I'll be showing you in a while. So first thing first, we have to know what are prime numbers, right? I'm going to show you two different kinds of numbers that we're going to look at. Natural numbers, like let's say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. These are natural numbers, right? We also have numbers that are divisible, divided by exactly 2 natural numbers. So I'm going to show you what's the difference right over here, right? So let me just show you a few examples of the numbers and what are prime numbers and what's not a prime number. So let us look at the first natural number, which is 1. 1 is not a prime number because 1 times 1 is already 1. Get it? 1 times 1 is already 1. There's no 2 natural numbers in it. So it's not prime. Whereas, let us look at this next one, which is 2. Now, 2 is a prime number. Why? Because when 1 times 2, you get 2. So you have 2 natural numbers here. So this is a prime number. So it goes on and on and on. Even sometimes in different schools or different teachers or even different kind of exams, they will ask you to list of prime numbers, and yes, you have to write all of them. Maybe all of them up until maybe 10 or above or something like that, right? So it depends. So in this case, 2 is a prime number because 1 times 2 is 2. We have 2 numbers right over here. You cannot times anything else. Let us look at number 3, right? Number 3. 1 times 3, it is 3. So yes, this is also a prime number. Prime number, right? Now let's look at 4. All right, so 1 times 4. Correct, there are 2 numbers. But there is also another number where we can times to get the number 4, and that is 2. So with 1 times 4, you get 4. 2 times 2, well, yeah, you get 4. Again, over here, it is not exactly 2 numbers anymore. We want exactly only. So 4 is not a prime number because there's 3 natural numbers over here. So it is not prime number. So I'm just going to show you how to actually find out. All right, you're not going to write out what is prime number, what is not prime number like that, because I'm going to give you one whole list of numbers up to 100. So yeah, just pick your choice whether you want to memorize it or if you want to, let's say, do this style so you can actually find out no matter what number it is. Maybe if I tell you a certain number, then you can tell me right away, is it prime or not prime? And I'll be asking you to do that in a little while on your own, then I'll be giving you the answer. All right, let us look at 5, the number 5. So 1 times 5 is 5 over here, right? So other than 5, we're gonna look at 6, all right? Oh yeah, one thing is 5 is also a prime number because, well, there's only 2 numbers, 2 natural numbers, that's all. Now let's look at 6, shall we? So 6, well, 1 times 6, you have 6. What other numbers do we have? Let's see. We have 2 times 3. That's also one of it. So we actually have 4 natural numbers right over here. 4 natural numbers. So does that make it a prime number? Well, no, it's not a prime number, right? So over here, not prime. And let's go to just number 7. I'm showing you a bit more numbers so that you can see the differences, all right, and well, understand it a little more better. So I'm gonna use blue over here. 7. 1 times 7, you get 7. Any other numbers? No, we don't have any other numbers, right? So what we're gonna do is we're gonna write it down as a prime number. Prime. What if you have even bigger numbers? Right, I'm slowly gonna go bigger and bigger so you can see. Let's say 16, right? So 1 times 16, it is 16. Any other numbers? Think, think. We have quite a lot for this one, right? 8 times 2, or 2 times 8. It is also one of it. What other numbers do we have? We have 4 times 4. Yes? So 4 times 4 is also one of it. So there's a lot. Natural numbers over here. There's a lot. So it is not a prime number, right? Not prime. So let us circle over here. Actually, you don't have to circle, but I'm circling it so, well, just an example for you to see. Next, let's go to even bigger number. Let's say, not even bigger. Let's try one more first. Right near to it, which is 17. We have 1 times 17, you get 17. You don't have any other numbers to get 17. So basically, yes, this is a prime number. All right. Now the next thing, I'm gonna let you try on your own. Just for a while, you pause it, then you try it out. See if you can get it. Let's say it's 51. All right, this is the number that we want to see. So I'm gonna highlight the rest while you pause it and think, calculate in your mind. Is 51 a prime number? Or is it not a prime number? Right? All right, so I'm going to continue with this. 51, 1 times 51. Yes, the number can be big, so you're like, I don't know what to do. Well, what you can do is you divide by 2, divide by 3, divide by 4, and see if you have any remainders or not. If there are remainders, well, you're not really getting the correct answer, right? So we want it to divide it fully, nicely. So when we have, let's say, 3 times 17, you get 51. So this is not a prime number. You have 4 different numbers, 4 different factors over here. So over here, 4 different natural numbers, meaning it's not prime number. It's not prime. All right. So there is a list, and the list is actually right at the next page over here. 1 is not a prime number because 1 times 1 is 1, not 1 times 2. You only have one number. All right. Remember, you have to be able to divide by 2 natural numbers. Only then is counted as a prime number. So prime numbers up to 100, you have numbers like 2, 3, 5, 7, 11, 13, 17, 19. So if you notice very, very carefully, all right, there is not much of a pattern over here. So you have to check over here. You see one whole line itself is not a prime number itself. So you have to calculate one by one or even try to memorize it by yourself. All right. And that is all.